Today we're looking at the Unit 7 radicals. Today's our first lesson, so 7-1, roots and radical expressions. Today's date is 5/6/21. And I am learning to find the nth roots, and I'm learning to simplify radicals. So the big thing with that one is nth roots just means that we can find square roots, cube roots, fourth roots, so like it could go up to bigger than just our normal square root, cube root. And we're going to look at how to simplify radical expressions too. So our radical is set up like this right here. We have let me grab my pen, our radical. And then inside of it we have x to the whatever power, so we'll just put to the power m, and then our little guy here, our n is like our nth root. It's like when we say we're learning to find the nth root, that's because this number here can change. That little guy there, usually we're used to saying square roots, cube roots, those are the ones we've seen most commonly. That's called our index. So that little guy there in front of our radical, that little number, he's called the index. It's really important to know about him. Now the bar itself, that is the radical. So when you hear me say radical, that's just that bar. And our x on the inside, he gets a goofy name. He's called the radicand. There we go. That's all of our parts to the radical. And we'll be using all these definitions for it. So make sure we kind of know what every part is. So our index is the little number in front of the radical bar. Our actual bar is called the radical. And then whatever is inside the radical is called the radicand. So steps for reducing our radicals. Step 1 is we want to make sure that our coefficient, so make sure coefficient or the number, whatever number you have there, so coefficient or number is perfect to that root. Because remember, we're doing more than just perfect squares and perfect cubes. You'll probably see a couple of ones that are a little bit bigger than that. So we have to make sure that that coefficient or the number, whatever we have inside that radical, our radicand, is a perfect to whatever root we're given. All right, so step 2. If we have any variables, so if variables, what we do is we divide their exponent by the index. So that's really important why we had to know what all the parts to our radicals were. Because that index is that little number in front, so we have to divide our exponents divided by the index in order to reduce that. And lastly, we'll make sure we simplify fully. Now, there's one last thing I always like to talk about when I say the simplify fully. You all don't have to write this out, but just kind of think about it with me. What is the square root of 4? 2. So whenever you write your answers, you don't have any radicals when you take the root. So there we go. The radical disappears. And the big thing with that one, just realize how we said the square root of 4 was 2. Oh no, it jumped on me. Same way there. Anytime you take any of those roots, it's going to disappear. So we're not going to have the square root bar, or cube root bar, or fourth root bar left after we take that root. So next we're going to look at just our perfect squares first. So to make your perfect square list, we're just going to go through there and square numbers. Like we start with 1, so what is 1 squared? 1. You got 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. And if you need any more after that, you can kind of keep going if you need to. I always like to kind of highlight this portion here because all of these numbers here are the perfect squares, what they equal to. Now, if you need to know, like, what is the perfect square of 25, then you can just follow it over and say, oh, it's going to be 5. So remember, it's what they equal to. Those are your perfect squares. So make sure you kind of realize it's that what they equal to. And now we've done our perfect squares. We're just going to go over there, do the same thing for our perfect cubes. So, what's 1 cubed? I enjoy 1 cubed. 1 cubed is 1, because 1 times 1 times 1 is 1. Alright, 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So our 11 cubed is 1331. And our 12 cubed is 1728. There we go. That's our perfect cubes. Once again, it's this part right here that they equal. This is the most important part of our perfect cube list. We just write those numbers out the side of it, so when they ask us what is the perfect cube of 729, we can just say 9. There we go. So this next part says, what are the real cube roots of these 3 numbers? So when it says real cube roots, that means we're going to have our index be 3 because it's a cube, and then make our radical bar. So for like example 1, the first one we're going to take the cube root of is 0.008. Okay, so for our friends at home, if you all will go to Desmos, to get the cube root on Desmos, and for those of you who ever need to do these at home, is this button right here. So like if you set your a to the b power and go below it, you get the n. We're going to put in there 3 for the cube root. And then your 0.008, then hit enter, and it gives us the 0.2. We get 0.2 for the first one, and now we just keep on going. We're going to take the cube roots of this next one. So what is the cube root of 1,000? Sorry, negative 1,000. Very good. Why is it a negative 10? Because it's a negative 1,000. Think about it backwards. You'd have to cube negative 10. So like what would be negative 10 times the negative 10? It'd be positive times a third negative 10 would make it a negative. So you can take the cube roots of negative numbers because you have an odd amount there. Then lastly, our cube root of 1/27. So once again, you can put that into the calculator. Alrighty, so once again, to do cube root of a fraction, we're going to hit our nth root button, put the cube in there. Over here, we're going to hit our fraction button, a over b, and then hit 1/27, enter. And it gives us 0.333, but where it's written as a fraction, we want it as a fraction, so we hit the convert to fraction button, and it's 1/3. So over here, we just write 1/3, and we're good. Now, example 2, we're asked to find each of these real roots. So 2, we're once again asked to find the cube root of a -8. So what would be the cube root of -8? -2. Because once again, -2 times -2 times -2 would be a -8, so we're good. All right, B, we have the square root of a 0.04. So what's that going to give us? You got 0.2. And now our last one, we have the square root of a -2 squared. So the square root of a -2 squared. What do you think we could do first there? We can write -2 squared. So what is -2 squared? 4. So it's actually the square root of 4. And what is the square root of 4? 2. And we're good. So here at example 3, we're going to start to add in our variables and our exponents. So our a here at 3 is the square root of 16x to the 8th power. So this is where our steps kind of come into more play. Is 16 a perfect square?
Yes.
Yes, he is. All right. So now it's a square root. So what is the square root of 16? 4. Now what did we say we had to do if we had variables? You got divided by the index. Where it's a square root, what's our index number there? What's a square root? 2. So every time you have just a square root, its index is 2. So square roots have index of 2 because if you think about it, a square is an exponent. A square root's index is 2. Because a square's exponent is 2. So like they're kind of opposites that way. So now we're going to have to divide the exponent by the index. So what is 8 divided by 2? 4. Alright, so we get our x then, and 8 divided by 2 is 4, and we're good. And once again, because we took the root of that, we have no radicals left in our answer. Alright, so B switches over here to a cube root. So B is the cube root of a to the 6th and b to the 9th. So now, there's no coefficients to worry about, so what do I do with my variables?
Divided by 3.
You got divided by the index. So if that's a to the 6, well what's 6 divided by the 3? 2. And you got in b, if that's to the 9th, what's 9 divided by the 3? 3, so b to the 3rd. And we're good. Alright, so then our part C down here, we have the cube root of a -9 to the 6th power. So even though we have the cube root of a -9 to the 6th power, I'm going to go ahead and just divide that exponent by the index. So 6 divided by the 3 is going to be 2, so I'm going to get -9 squared. Then -9 times -9 gives me a positive 81. Now, if you were to type that whole thing into the calculator, it would give you the same answer, where it's just a number and no variables. But sometimes it's a little bit faster to just divide the exponent by the index. Alright, part D now, we have the square root of 64 with x plus 1 to the 8th power inside the square root. So the first thing we need to do is just take the square root of just our 64, and that gives us 8. And now we're going to treat this whole parentheses as one thing because that's a whole group together by itself. So remember it's a square root, so my index is 2. So we're going to do our 8 divided by our 2 and get 4. So we get this parenthesis x plus 1 to the 4th power. And that's our answer. We don't have to simplify it. We don't have to keep going because that whole parenthesis we just treat as one term. There we go. Alright, so for our next one, we have E is the square root of 25v to the 4th. So the first thing we do is just take the square root of 25, which is 5. And now we divide the exponent by the index of 2. So 4 divided by 2 is 2. So v squared. And we're done. All right, D. We have the cube root, or sorry, F. My fault, F. Forgot what letter of the alphabet we were on, F. We have the cube root of 512 m to the 6th n cubed p cubed. So first thing we're going to do is take the cube root of 512, which is 8. And now we're going to take each exponent and divide it by the index of 3. So 6 divided by 3 is 2, so m squared. All right, n cubed, so 3 divided by 3 is 1, so it's just going to be n. And then p cubed, so 3 divided by the 3 is 1, so it's just p. And we're good. Now, our last example for this part has the square root of x squared minus 6x plus 9. If you remember, it looks like our trinomial form, our ax squared plus bx plus c. So it's a trinomial that we need to factor. Because we're going to factor it, we have to remember our two main parts of factoring for a trinomial. We have to find the numbers that will multiply to c and will add to b. So if we look here, our c is 9, so he's a positive 9. Factors of 9 are 1 and 9, and 3 and 3. And because he's positive, they're going to be the same sign. Where he's a negative 6 for my b, I'm going to make both these guys negative. So negative, 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 negative. And find which set of factors add to b. And that would be my negative 3 and negative 3. Now, this step is still inside that square root bar. So we'll end up with our two parentheses for our answer for a trinomial, where it starts off with x squared. We put x first in each parenthesis. And now we said a minus 3 and a minus 3 would add to a negative 6. So we'll check it really quick for our OI. So x times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is a negative 6x, which checks for what we needed. Now, if we look here, we have the same parenthesis written twice, which means we can take that parenthesis of our square root of x minus 3, instead of writing it twice, we can now square it. Because having two of them means I can square it, because x minus 3 squared means I have two of them. So it's just another way of writing the same answer. Now, where it's a square root, our index here is 2. And we're going to do the same thing we did last time. We treat this whole parenthesis like it's one term. And we're going to say the exponent's 2. So 2 divided by 2 is actually 1. So we're just left with our x minus 3. If you want to show to the first power, you can, but we don't have to. And we're all good. All right, so for this last part, example 4 and A, we now have x squared equals 25. And we're asked to solve each equation. So to solve the equation, you have to do the opposite operation. So if you have x squared, you have to take the square roots of both sides. So now, what is the square root of x squared? What happens there with a square root and a squared? You divide it. It's like, what is 2 divided by 2? 1. Do I have to show the exponent? Nope, so it's just the x. So your square root and your square are opposites, and they technically cancel each other out like that right there. Now, equals, and what is the square root of 5? Or sorry, 25. I gave you the answer. My fault. Square root of 25 is 5. That was my fault. Now, there is one thing we have to think more about with the equations. We have to come up with every solution that could be the square root of a positive 25. So I know positive 5 times positive 5 is 25. But what else will also multiply to a positive 25? Negative. So it could be a plus or minus 5. Because positive 5 times positive 5 is a positive 25. But also a negative 5 times a negative 5 is a positive 25. So we'll talk about that here in just a little bit at the end. But realize now we're going to have to kind of look at all the possible solutions you could get for it. All right, so B, we have the cube root of 64. Or I'm sorry, x cubed equals 64. I gave you the next step too. I'm thinking a step ahead here. So if I have x cubed equals 64, what's the opposite of a cube? Cube root. So I take the cube root of both sides. And now, what happens with my cube root of x cubed? It's just going to be x because 3 divided by 3 is 1. Also, cube root and cube cancel, however you like to think about it. Now, what is the cube root of 64? Cube root of 64. 4. Yeah, cube root of 64 is just 4. Now, it's a positive 64. So you got to think about a cube means times 3. So like a positive 4 times a positive 4 times a positive 4 gives you a positive 64. So we know it has to be positive. But could it also be negative? Could you get a negative 4 times negative 4 times negative 4? Would that give you a positive 64? No, because you have an odd number of negatives. So a negative times a negative makes that a positive, and then a positive times another negative would be a negative. And it's not a negative 64, it's positive 64. So what does that mean for my answer here? You guys, it's only going to be positive 4. Very good.
Do we need to put the...
Alright, C, we have x to the 4 equals 16. The same way we're solving the equations, we have to do the opposite of the exponent. So what's the opposite of x to the 4th? You got 4th root, so we'll take the 4th root of both sides here. 4th root, remember you can use that part of the calculator that has the radical where you can put in your index of 4. So we know 4 divided by 4 is 1, and the 4th root and 4th exponent cancel, equals, now what is the 4th root of 16? 2. Now we have to think about it like we did before. We know 2 times 2 times 2 times 2, so all positive means we're going to get positive 16, so it can be positive. But can all the 2's also be negative? Yes, because a negative 2 times negative 2 is positive. A negative 2 times negative 2 is a positive, and then positive times positive is going to give us a positive 16. So that means he could be a plus or a minus 2. So he could be a positive or a negative to work for that one. All right, D. We got x squared equals a negative 81. I love this one. Because what's opposite of square? Square root. So we're going to take the square root of both sides. Apparently I showed the index there of 2. Because we're going to have to say 2 divided by 2 is 1. So you get just x. And like we said, square root and square cancel and leave you with just x. Now, how do I take the square root of a negative 81? You got times it by the negative 1. So you get square root of 81 and the square root of a negative 1. So now what is the square root of 81? Square root of 81. 9. And now square root of negative 1. Square root of negative 1 is I. Remember that from the test we just took? So that guy still is there. And now we kind of have to check it to make sure if we get negative 81. So like, if you have 9i, I times 9i, well, 9 times 9 is 81. I times I is I squared. I squared becomes what? Negative 1. So I'm going to mark him out, make him a negative 81. That's what we wanted. So we know he can both be positive 9i's, but can they both be negatives? So that's the other one to check for. So we get rid of that and make them both negative now. So it's a negative 9 times a negative 9. Negative 9 times negative 9? Positive 81. I times I is I squared. What does I squared do? Make it negative 1, which makes that a negative 81. So does that work? Yeah, so it can be plus or minus 9i. All right. Last one. Cube root of a negative 27. Sorry, cube root. Oh, I gave you the step. Oh, we have x cubed equals a negative 27. So, for our last one here, we know what's the opposite of the cube? Cube root. So we take the cube root of both sides. Our 3 divided by 3 is 1. And now, what's a cube root of a negative 27? Well, it's a cube root of negative 27. Well, it's a cube root this time, so cube roots are a little bit different. Can you do that? What is a cube root of a negative 27? Huh? Negative 3. And that's because a negative 3 times a negative 3 is positive 9. And then what's positive 9 times a negative 3? It's going to be a negative 27. There you go. So that's what we started out with, negative 27. So we know it can be negative 3, but we got to check it. Can it also be a positive 3? So what's positive 3 times positive 3 times positive 3? It'd be a positive 27. So does that work? No. So he can only be just a negative 3. Now, here's the rule of thumb that's really good to have. If you look across our examples, every time the exponent was the exponent and the index was even, so 2, our index was 2, 4, 2. What do we get every single time that index was even? You got an plus or minus. We're going to get a plus or minus there every time you have that even index. So if you want to make yourself that note, even indexes have the plus or minus. And then that way you don't have to check it every time. You can just know even indexes receive the plus or minus symbol. Odd exponents only, the odd exponents, the odd indexes only receive one symbol. So 3, 3, they only receive a plus or they only receive a minus. So only one symbol. So odd indexes receive one symbol. And then we're good. Now, as far as it goes, our radicals, we've seen a couple of different parts. We've seen where we did just the roots of numbers. We've seen where we've done roots of our terms, where we have a number and a variable. And now we've seen where we solve equations with our roots. So hopefully you're all good. If you have any questions, let me know.